All right, so buckle up, listeners, because today we are going deep, 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 deep.
Deep dive time.
Exactly. We're talking Bitcoin, but not just, the Bitcoin you see on the news every day. We are going all the way back to the OG Bitcoin, back to the year 2008.
Back to the beginning.
To that white paper, 2008. The financial world is, let's just say, not having a good time in 2008. Kind of chaotic.
Yeah.
And out of nowhere, this mysterious, to this day is still unknown, Satoshi Nakamoto drops this document, very simply titled, Bitcoin, a peer-to-peer electronic cash system. Talk about perfect timing.
Yeah, you couldn't ask for better timing for something like this to drop.
Honestly, no. And reading this paper, and not gonna lie to you, it's dense. It can be a little bit of a head scratcher at times.
Yeah, you kind of need like a PhD in cryptography.
Yeah, you kind of need a little bit of help to unpack some of the ideas, which is what we're here for, luckily.
Here to make it make sense.
To break it down into, its base elements so that you can have those aha moments and really grasp the elegant genius of Bitcoin.
Right, because it is elegant when you get down to it.
It really is. It really is. So to set the stage a little bit, imagine you want to send money to someone online, like completely peer-to-peer, no banks involved, no middleman, no nothing, just pure digital cash zipping across the internet like magic.
Sign me up.
Right, that's the dream, right? The problem is there's a catch. There's a big catch. There's a catch that before Satoshi, almost everybody else who had tried to solve this problem had stumbled over.
Yeah, they just hit a wall. Couldn't get over it.
Couldn't figure it out. So what is this hurdle, this giant hurdle to digital cash?
It's the double spend problem, right?
Yeah.
And this is something that once you kind of hear it, it seems so obvious, but it was the main thing that was in the way. Think about it this way, right? If you have a digital file, a song, an image, whatever, you can copy and paste that an unlimited number of times. So how do you stop somebody from doing that with digital money, from spending it in one place and then instantly just making a copy and spending it again somewhere else?
Yeah, it's like that moment in a movie where the hero realizes, oh no, I'm up against a master forger. But instead of paintings, they're forging digital dollars.
Exactly. It's like digital counterfeiting.
Right, right.
And the hard thing is, in the digital world, you can't just be like, hey, that dollar's fake, because it looks exactly the same.
Exactly. Every digital dollar looks exactly like every other digital dollar.
Yeah. So back in 2008, the systems that did exist, they relied heavily on trust, right? It was all about having a bank or a credit card company,
right,
some big institution, be the central authority.
The referee, basically.
Exactly. They were there to make sure nobody was, making copies and spending them everywhere.
Yeah.
But of course, like Satoshi pointed out, that reliance on trust, it's got its own issues.
Right. So let's maybe unpack that a little bit, that trust issue. What were the downsides of having to rely on these institutions for every online transaction?
Well, first and foremost, it's expensive. Every time you swipe your credit card or you're doing stuff online, someone's taking a cut. Imagine if every email you sent, every cat video you watched online, you had to pay a fee. It would get out of control.
Yeah, the internet would grind to a halt.
Right. No more free cat videos. And it wasn't just the fees. It was that it kind of limited who could even get in the game in the first place. Not everybody has access to a bank account or credit card.
Especially in certain parts of the world.
Yeah, exactly. So it's not exactly the free and open financial system of the future that, we were all hoping for.
It was kind of like the opposite, putting up barriers instead of breaking them down.
For sure. And on top of that, you're always at the mercy of whoever that central authority is. Like, what happens if they decide to just block your transaction one day? Freeze your account, you're kind of stuck, right?
You're at their mercy. So Satoshi comes along and says, what if we just get rid of the middleman altogether?
Exactly. Like, let's cut them out.
No more relying on banks or governments to be the referee. It sounds great in theory, but how do you even begin to build a system like that? Where do you even start?
Well, it starts with addressing that trust issue head on.
Right.
Instead of having trust be based on, some institution, Satoshi had to find a way to build that trust into the system itself.
Okay.
And do that not through some company, but through math, through clever code.
Wait, so you're telling me this whole Bitcoin thing, this whole cryptocurrency revolution, it all boils down to some really, really complex math problems?
Basically, yes. It's all about the math.
Yeah.
One of the first tools that Satoshi looked at were digital signatures.
Okay.
Think about it like a unique digital fingerprint, but for a transaction.
Okay.
Right. They can prove who sent what. And here's the thing.
But they don't completely solve that double spend problem, do they?
They don't.
On their own.
Not quite. They can tell you who signed the transaction, but there's nothing in there to prevent that transaction from just being copied and sent again. It's kind of like if you signed a contract, but you signed it in disappearing ink.
Ooh.
It looks official at first, but then, poof, it's gone. Good luck proving that you actually signed it.
Right. So if digital signatures were only part of the solution, what was the big breakthrough? How did Satoshi propose to actually tackle this double spending problem?
That's where this idea of a decentralized timestamp server comes in.
Hold on, rewind.
It might sound a little Back to the Future at first.
It does, okay.
But it's actually the seed of what we now call the blockchain.
Okay, slow down. A decentralized timestamp. What are we talking about here? You're going to have to break this one down for me. All right, so we've got these digital signatures, which are cool, but on their own, they're not enough to solve this double spending puzzle. And now you're hitting me with this decentralized timestamp server thing, which honestly sounds like something out of Back to the Future. Like, what are we even talking about here?
You're right. It's not immediately obvious how all these pieces fit together, but that's kind of what makes Satoshi's thinking so, like, out there. He took all these existing concepts and combined them in a way that nobody had ever really thought of before. So about this timestamp server. Imagine like a notary public, right? But for digital information. So you have a document and you want to make sure nobody can tamper with it. You take it to the notary, they record it with a date and time, and bam. Now it's a lot harder to change things without people knowing. That's kind of what a timestamp server does, but in the digital world, it takes a piece of data, like a transaction, and slaps a timestamp on it. Proof that this thing existed at this particular moment in time.
Okay, that makes sense. So it's like instead of needing a bank to be the one that tells us when a transaction happened, we've got this like digital notary in the sky or something. But then how do we know that nobody's messing with the timestamps themselves?
That's where the decentralized part comes in. Satoshi didn't propose just having one timestamp server that everybody had to trust. Instead, he imagined this whole network of these servers, all working together, each one with a copy of all the timestamp transactions.
Ah, okay. I think I'm starting to see where you're going with this. It's starting to sound a lot like a blockchain, isn't it? Like each block is kind of like a page in the timestamp server's logbook, and they're all connected together somehow.
You're getting warmer. But there's still one really important piece that we haven't talked about yet. How do we get all of these servers, or nodes as we call them now, how do we get them to all agree on one single history of transactions? How do we make absolutely sure that somebody can't just like sneak in a fake transaction or change one of the timestamps to their advantage? To understand that, we need to take a quick little detour. A detour into the surprisingly related world of spam prevention.
Spam prevention. Wait, you mean like those annoying emails that promise if I click this link, I'll get rich quick? What does that possibly have to do with Bitcoin?
I know it sounds crazy, but trust me, this is where things get really interesting. Before Bitcoin was even a thing, there was this programmer, Adam Back. He came up with a system called Hashcash. The idea was to make it so that sending an email, any email, would take a tiny, tiny bit of computing power. Like not even noticeable if you're just sending a regular email to a friend. But it would make it way harder for spammers to send out thousands or millions of emails at once.
So it's kind of like making everyone solve a tiny puzzle before they can hit send on their email.
Exactly. And the puzzles that Hashcash used, they involve these things called hashes, which you might have heard of before.
Yeah, vaguely.
They're kind of like digital fingerprints, but for any piece of data. So like you put some data into this thing called a hash function. Could be a sentence, a whole book, a song, anything. And the hash function spits out this unique code. Now here's the key thing. You change even one single letter in that original data, just one tiny change, and you get a completely different hash. Hashcash made it so that senders had to find this special number. This number that when you combined it with the data from the email and put it through the hash function, it would make a hash that started with a certain number of zeros.
Okay, I kind of remember hearing about hashes. They're like those checksum things, like when you download a file and want to make sure it hasn't been corrupted.
That is a fantastic analogy.
Yeah.
They're like a digital fingerprint for the data to make sure that it hasn't been tampered with. Now, here's where Satoshi's real genius comes in. He took this concept of requiring computational work, something that Adam Back came up with for stopping spam, and he applied it to the world of digital money. Instead of just letting anyone add timestamps to the ledger willy-nilly, Satoshi made it so that creating a block in the first place was intentionally computationally expensive. It takes actual effort, actual computing power. This is what we now call proof of work.
Hold on, so let me see if I'm understanding this. So instead of just being able to say, hey, here's a new block of transactions with timestamps on it, you have to actually prove that you spent some serious computing power to create this block.
You got it. That's exactly it. It's kind of like saying, look, I've done a ton of work to find this super rare digital artifact, and just so happens this block of transactions was attached to it. And this proof of work, it's what makes it not impossible, but really, really, really difficult for anybody to mess with the blockchain.
Okay, so walk me through how this works in practice. How does proof of work actually make the blockchain secure? Give me the step-by-step.
Okay, so proof of work is like this digital gauntlet you have to run to get your block added to the chain. But what's the incentive for anyone to actually do it? It can't just be for the love of the game, right? You're exactly right. All of that computing, all of those calculations, it takes time. It takes energy. There has to be some kind of reward, right? And Satoshi, being the clever, brilliant person that they were, they built that right into the system. Remember we were talking about how miners are all competing to solve these proof-of-work puzzles? Well, whoever manages to crack the code first, not only do they get to add their block of transactions to the chain, but they get a reward. They get paid for their efforts.
Wait, so they get paid in Bitcoin for securing the network? Talk about a win-win.
Yeah, it's a pretty ingenious system when you think about it. It's often compared to, like, gold mining.
Okay, I see that.
You're putting in a lot of effort, using resources, and if you're good at what you do, and maybe a little bit lucky, you find some gold. Except in this case, instead of digging in the dirt, you're, flexing your computer's muscles, unearthing that digital gold.
So let me get this straight. New Bitcoins are created as a reward for this process, for securing the network. That's how they come into existence.
That's exactly how it works. It's all built into the code. Yeah. And just like with gold, there's only a finite amount of Bitcoin that will ever be mined. 21 million to be exact. So the more Bitcoin that's out there, the harder it becomes to mine new Bitcoin.
It's like a self-regulating treasure hunt.
Yes.
That's so cool. And I imagine that scarcity, that limited supply, that's a big part of what gives Bitcoin value in the first place, right?
100%. And then on top of that block reward, miners can also earn these transaction fees.
Oh, right.
So when you make a Bitcoin transaction, you can choose to add a little fee on top.
Okay.
And that little fee incentivizes the miners to include your transaction in their next block. So the higher the fee you pay, the faster your transaction is likely to go through.
So you're basically like slipping the miners a little tip to cut in line.
Exactly.
Makes sense. But with all this talk of, these public ledgers, these transactions that everyone can see, at least in theory, what about privacy?
Right.
It seems like with Bitcoin, everyone's business is just out there in the open. How does that work?
Yeah, it's definitely something that people were and still are concerned about. And actually, Satoshi dedicated a good portion of that white paper to talking about privacy. Right. So it is true that, in a way, Bitcoin transactions are public, at least in the sense that they're all recorded on the blockchain for anyone to see. But how Bitcoin handles your identity, that's where things get a little more interesting.
Okay, because I was going to say, how can you have privacy if everyone can see every transaction?
So think of it this way, right?
Yeah.
When you use Bitcoin, you're not using your real name, your address, your phone number, anything like that. Instead, you have these things called keys. You have a public key and a private key. Your public key, that's kind of like your Bitcoin address, the one you can share with other people so they can send you money. Your private key, on the other hand, that's like your super secret password that you and only you should ever know. That's what you use to actually authorize transactions.
So it's like a secret code that proves that I'm the one who's actually allowed to spend this Bitcoin.
Exactly. And these keys, they're just these long strings of like random numbers and letters.
Yeah.
Just by looking at them, there's no way to tell who they belong to unless, you go around telling everyone, hey, this is the key to my Bitcoin stash. Come and get it.
Right. Don't do that. So if somebody is like snooping around on the blockchain, they might see all these transactions happening between these anonymous keys, but they wouldn't necessarily know who those keys actually belong to in the real world.
Exactly. It'd be like having a masked ball, but for digital money.
Ooh, I like that. Okay.
Right.
So with Bitcoin, it's more like having a pseudonym than being completely invisible.
Yeah.
Right.
Right.
You have to be smart about how you use it.
Exactly. You do have to be careful about your privacy if you want to make sure that those transactions are kept as private as possible. And that's actually a great point to kind of wrap things up on. Satoshi's white paper, it didn't just create this technical blueprint for how to build Bitcoin. It really sparked this whole new way of thinking about money, about digital money, about trust, and how we build systems on the internet. It's like Satoshi threw open this door to this world of possibilities, but it's up to us to figure out how to walk through that door responsibly.
And what a door it has been. What an impact this white paper has had. We've only just scratched the surface here. But I think it's clear that even though this white paper was written way back in 2008, it still has the power to, like, really make us rethink everything we thought we knew about money and the internet and technology as a whole. This is a story that's still being written, and who knows what's going to happen next. If this deep dive has piqued your curiosity, don't stop here. This is your sign to go out there and do some more research on your own. Until next time, keep asking those questions, keep learning, and keep diving deep.